In this video, I want to have a look at something called limits of accuracy. So all measuring instruments have a limit of accuracy because of their level of precision. So we're saying whenever we measure something, we can't be 100% accurate, but sometimes we can be more accurate than others depending on what we're using to measure. So to help explain that, we're going to have a look at the example of measuring somebody's height. So here I've got drawn part of a measuring tape or a ruler, and what we have marked are the centimeters. So 172, 173, 174, and 175 centimeters, and there's no markings between there. So because I'm a pretty terrible drawer, we're going to have a look at this little cartoon guy. Now to measure him, we're going to have a look at the top of his hair here. So if we would draw a line straight across there, we can see that his height lines up here on our ruler. Now, because our ruler only has centimeters, we're going to measure him to the nearest centimeter. So if we were doing that, we would say that he was 174 meters, centimeters, not 174 meters, 174 centimeters tall. But you can see that we weren't being 100% accurate because we were only measuring in whole centimeters. So because we were measuring centimeters, he could have been anywhere from here to here, so we could have been anywhere from 173.5 to 174.5. Any height in between there would have been rounded to 174 centimeters. So what we say is the level of precision here is plus or minus 0.5 centimeters. So this is our limit of accuracy because we could have gone half a centimeter above, so plus 0.5, or we could have gone half a centimeter below, so we could have minus 0.5, and we still, anywhere in there, we still would have rounded to 174. Now, what if we have a look at that same problem of measuring this person's height, but this time we're using a ruler that has millimeters marked as well. So now we can be a lot more accurate because we can measure to the nearest millimeter. So if we have a look at here, this one here would be 173.6, and this one here would be 173.7. So by the looks of where I've drawn my line there, it looks like it's going to be closest to 173.6 centimeters. Now again, that's not 100% accurate as you can see, but this time I could have only gone a maximum of half a millimeter up and half a millimeter down before I would have ended up rounding either to 173.7 or 173.5. So this time my accuracy would be plus or minus 0.05 centimeters, or we could say 0.5 millimeters. So I'm a lot more accurate this time, and this time my limit of accuracy is this number here. So more generally, the limit of accuracy is always going to be plus or minus half the smallest unit shown on the measuring instrument. So let's have a look at a couple of other examples. So in our first example, we've got a car speedo, and every 5 kilometers per hour is marked. So even though it only says 10, 20, 30, because it's got those markings in the middle there, that means we can get it accurate closest to the nearest 5 kilometers per hour. So the smallest unit marked is 5 kilometers per hour, which means that our limit of accuracy is going to be plus or minus half of that. So half of 5 is 2.5. So our limit of accuracy is plus or minus 2.5 kilometers per hour. In our next example, we've got some bathroom scales. The units on there are 55.7 kilograms. Now it's measuring it correct to 1 decimal place. So the smallest unit would be 0.1 kilogram, which means that our limit of accuracy would be plus or minus half of that, which would be 0.05 kilograms as our limit of accuracy. And in our last one, we have a measuring flask, and you can see that every milliliter is marked there. So the smallest unit is 1 milliliter, which means that our limit of accuracy would be plus or minus half of that, so plus or minus 0.5 milliliters. So that's having a look at limits of accuracy.